In this video, over decimals, we're going to talk about just multiplying. So let's take a look. Let's review what we know about multiplication. All right? So if I were to give you this particular problem with whole numbers, what is it that you would do? All we would do is take our numbers, we would line them up, and we would multiply. Simple as that. We line them up according to the numbers. This is a 3-digit number by a 2-digit number, and we multiply. 6 times 3, 18. 6 times 5 is 30, plus 1 is 31. 6 times 4 is 24, 25, 26, 27. Okay. Move over a spot because we move over a spot in our digits here. 3 times 3 is 9. 3 times 5 is 15. Carry the 1. 3 times 4 is 12, plus 1 is 13. And then we add 8, 10, 7, 8, 9, 10, 11, 12, 13. 6, 3 plus 2 plus 1 is 6, and then 1. So we end up with 16,308. So all we do in a process like this when we're multiplying is we simply line up our numbers and multiply. Well, the nice thing is in decimals, we do basically the same thing, and we kind of will determine that by a process of estimation here. In this particular problem, I want us to multiply this one, but looking at it through estimation to try to determine where our decimal is going to go. So if we follow those same procedures that we just looked at for regular multiplication, all we have to do is line up our numbers. So we take our 7.2 and think of it as a 2-digit number. We have the 6, and we just line it up as a 1-digit number. So it's just 7.2 times 6. And we line up our numbers. We don't pay any attention to where the decimals are at. Because where would the decimal be in the 6? Correct. It would be back here behind it. So notice our decimals are not lined up. That's why we don't line up our decimals. You can, but it's going to be more work. So now we multiply. We don't pay attention to our decimal. 6 times 2 is 12. 6 times 7 is 42. Plus 1 is 43. So we end up with 432. Now we're going to do something called front-end estimation to help us determine where our decimal is going to go. Front-end estimation only uses the whole part of my problem. So in the 7.2, the whole part is 7. In the 6 is our whole part, so we're going to use the 6. And we're going to multiply those together. We end up with 42 as our estimate. So the approximate answer of 7.2 times 6 is 42. So based on that, could my decimal go here at the very end of the problem? No, because my answer is 432, way too big. Could it go between the 3 and the 2? Yes, that is reasonable based on my estimate. 43 is close to 42. Could it go between the 4 and the 3? No, the number would be too small. Could it go between or in the very front? No, because that number would be way too small. So based on our estimate, the only place the decimal could go is between the 3 and the 2. And sure enough, it is. And what we find out is, and what you've learned in the past, is that all you do is you count the number of numbers or the number of digits that are to the right of the decimal in my problem, add that up, and that's the total number of digits that you'll have in your answer. So in this case, we have 1, so I will have 1 number behind the decimal in my answer. So let's try another one. Right? So here's another one. Now this one throws in the idea of positive and negatives as well. Okay, and we do the same thing that we did with the previous problem. We line up our numbers, we multiply, we determine where our decimal is going to go, and now in this one we also need to determine what type of value am I going to have. Is it going to be positive or negative? So let's line up our numbers, 142 and 13, and that might be an easier way to do it. Pretend like the decimals aren't even there, line your numbers up, then go back in and place your decimals in, and multiply. 3 times 2 is 6. 3 times 4 is 12. 3 times 1 plus 1 is 4. Move over a place. 1 times 2 is 2. 1 times 4 is 4. 1 times 1 is 1. We add 6, 4, 8, 1. Now, we go through and we count how many numbers are to the right of my decimal. 1, 2, 1. So that is 3 total. So I should have 3 digits behind the decimal in my answer. Now I'm not finished yet. We know we get an answer of 1.846, but I have 1 number is negative. And in multiplication, 1 negative makes the whole answer negative. So when we're multiplying or doing any of these decimals, we've got to think about these integer rules as well. Even though these numbers aren't integers, they still follow the same set of rules that we talked about when we discussed integers. So really, what are the steps that we've used so far to multiply decimals? Well, the first thing is we line up our numbers. We don't line up our decimals, we line up our numbers. We multiply our numbers, and then we determine where the decimal goes. Well, how do I do that? How do I determine where the decimal goes in my answer? Well, I count the digits to the right of the decimal in each number in the problem, and then I move the decimal to the left in my answer, the number of digits you counted in the problem. So let's try one last one. Okay, 23.56 times 3.6 with both numbers being negative. Now, since both of these numbers are negative, we automatically know that my answer is going to be a positive because two negatives make a positive. Now all we have to do is line up our numbers, 23, 56, 36, add our decimals in so we remember where they're at, and we multiply. Move over a place. Now we add 6, 11, 8, 4, 8. So we end up with positive 8, 4, 8, 1, 6. In this number I have 2 places. This number I have 1. So I need a total of 3 places behind the decimal. So my decimal goes right there, 84.816. And that's how we multiply decimals.